So all the stuff that you learned for fractions is also true for rational expressions. You kind of do things more or less the same way. So when you learned how to reduce fractions, is it true that you learned to just divide the top and bottom by the same number? Yeah, okay. Here's another way to think about it. It's the same thing. Instead of dividing, just factor the numbers. So for example, 15 is 5 times 3. Does that make sense? And 21 is what times what? 7 times 3. And then what can cancel? The 3's, the common factors, right? And that becomes 5 over 7, and you're done. And we're going to use that same method to factor polynomials. So unfortunately, these two are the ones we have to do the long way. Ready for the long way? So let's do that on the side and then put in our answers. So first, let's factor 6x squared plus x minus 2. So what's the magic number for that one? Negative 12. So we need things that multiply to negative 12 and add up to positive 1 for negative 3. Who do you want to put first?
Negative 3.
Negative 3. Okay, so you got 6x squared minus 3x plus 4x minus 2. So what's your greatest common factor in your first two? 3x. 2x minus 1. How about the next two?
2.
2. And then 2x minus 1. So that's Gesundheit. 3x plus 2, 2x minus 1. If you're going to run out of space, because I assumed we were going to guess and check this, you can put this in example 2 under part A. There's plenty of space there. 3x plus 2, 2x minus 1. So that's just the numerator. Now how about the denominator?
2x plus 1.
Yeah, let's try to guess and check that one, because that one's pretty easy. So you could do it the long way. I think you guys can all handle that. But 2x squared had to come from 2x and x, right? Does that make sense? And you either have plus 1 minus 1, or what's your other option?
2x minus 1.
X plus 1. You just got to figure out which one of those two it is. Does that make sense? Move it up for a second. So is it the first one? When you multiply it together, you get 2x squared minus 2x plus 1x, which makes negative 1x, right? So it's not this first one. Is it the second one?
Yes.
Yes, so that's the one that it is. So you got 2x minus 1, x plus 1. If you don't like that method, you can use the other one still. It's not going to be wrong. It's just that that way is a bit faster. And now, are there any common factors that can divide out or cancel? 2x minus 1s. And that reduces to 3x plus 2 over x plus 1. And what I'm using for that guess and check, just in case it isn't clear to people, is that this term and this term have to multiply to make that guy. Does that make sense? And the last thing is that this thing and this thing have to multiply to make this, right? That's the pattern. Then you have to multiply them together to check. That's all. Okay. This next one's long and icky because it's that cube formula. So first of all, does it make sense that the numerator has the greatest common factor and so does the denominator? What is the numerator's greatest common factor? X. So we're going to have x times x cubed minus 8 over x times what else?
3x squared
Uh-huh.
minus 2x minus 8.
Great. Okay. Now those x's can cancel and they can be gone. Is that okay with everybody? All right. So you have x cubed plus 8 minus 8 over 3x squared minus 2x minus 8. Remember the hints I told you to look for is that the numerator is a cubed, and there's only two terms, right? So that's that formula from the last set of notes we had. So it'll be the a minus b, a squared plus ab plus b squared formula. So in the example of the numerator, what is your a? And what is your b? 2. So that will be x minus 2, x squared plus, what comes next? 2x. And then what's the last thing? Plus 4. Okay.
How come you use the a minus b?
How come I use, how come I use like this formula versus the one that has pluses in it? So you use the minus formula if that is a minus sign. Okay. It is also okay if you were to use the formula a plus b, a squared minus ab plus b squared. What you have to do is use a equals x and b equals negative 2. That also works. Does that make sense? So if you have this formula, you plug in negative 2, you get x plus negative 2, which is x minus 2 like we got, right? And then you get a squared is x squared, right? Minus negative 2x, which makes positive, right? And then plus b squared plus negative 2 squared makes negative 4. So I'm not sure why they do it this way, but all textbooks give both formulas and have you use the minus one when you have a minus sign and the plus one when you have a plus sign between the two things. You could only remember the plus one and then just plug in the negative for the b, and that will also always work. Okay? It's just tricky. Also, we didn't discuss it like super thoroughly, but does this x squared plus 2x plus 4 factor?
No.
No. Nothing multiplies to 4 and adds to 2, right? So that one's actually prime, and it almost, unless you've got a GCF, I think it's pretty much always prime. I don't want to say not always, but I'm almost positive it's almost always prime. Maybe a GCF, but no more. Okay, let's do the last one. 3x squared minus 2x minus 8. So what's the magic number there? Must add to negative 2. So what? 4 and 6, yep. 3x squared plus 6x. I boo-booed. That's wrong. What did I mess up?
Switch the symbols.
It should be minus 6 and plus 4. My bad. So 3x, x minus 2, and what's the GCF next? 4. So that denominator is x minus 2, 3x plus 4. Is it fair to assume most of you are going to do it that way? Do you like that way better? Yeah, okay. So I'll just make sure that when I make answer keys, leave enough space for that to be done, okay? Because I didn't really think that we'd do it that way here. So what's your final answer now? Great. Do those x's cancel? No. Yeah. So when you're at that step, the x from the 2x can't cancel the 3x. And the technical reason is order of operations, that big fraction bar acts like a parenthesis. And before you do any division, you have to first do all this stuff, then do all that stuff, then divide. The next thing that I have on your notes says don't kill any kittens.
What if you don't like kittens?
We're still not going to kill animals, okay? So this is just a goofy thing that I saw that I hope to make you remember. If you make a bad factor, I'm going to say you killed a kitten. I'm sorry. But this is just a goofy meme I found online. It said, whenever you do this, a kitten dies. Don't kill any kittens, okay? Yes?
Would you wanna like factor the top one,
Mm-hmm.
or is it just fine to leave it like that?
It is fine too, it just depends on the situation. In this particular problem where there was a bad thing that happened, the numerator does factor, right? What does the numerator factor into? X plus 1 and x plus 1. And the denominator is prime. Does that make sense? Yep. So I think that it just depends on the situation. I'm going to have to be pretty clear in my directions, like what I want you to do. Does that make sense? So if you know that when you factor, nothing's going to cancel, you can leave it multiplied together. Does that make sense? So I will either have to have really good directions that tell you exactly what I want, right? Or I will be checking to see, like, did something cancel? Does that make sense? So in general, I take either this one or that one, unless I explicitly ask for this one some way. Does that make sense? I'll try to make it totally clear. I'm not sure how I would. But what I would be mostly checking is, could you even in your head just see, does this factor and cancel with that? And no, it doesn't. I can just leave it. So either way is okay. But the point is, those x squareds don't cancel them. Okay?
When is it correct to factor with I?
When is it correct to factor with I? And that one wouldn't be the x plus root 3, x minus root 3. The technical reason is when the directions say to factor over the imaginary numbers.
Okay.
Okay, so we're not going to use i's very much in this class. Only a little bit. Have you guys all seen i's? Yeah. Do you have a question, Tani?
Yeah, on the end result for C,
Yes.
the top one is x squared plus 2x plus 4. If we got that by itself and you said to factor,
It doesn't factor. It doesn't factor.
So we would just say not.
It'd be prime. Kind of like this x squared plus 3 doesn't factor either, right? Same idea. So there are some polynomials that are prime, they don't factor. So that's it, they're done. And part of it is like that, and mostly those are going to be really obvious ones. Like there are the things that multiply to 4 are 1 and 4, which adds to 5, right? 2 and 2, which adds to 4. Nothing adds to 2. They should be pretty obvious ones. Okay. So that's reducing. So also multiplying. So multiplying kind of is reducing in disguise. We did a question like this early on, and the hard way is to multiply 8 and 7 and 21 and 16 and then reduce, right? What's the easy way? Yeah, I think that most people call it cross-reducing. Does that make sense? You can reduce the 7 and the 21 to 1 over 3, right? And you can reduce the 8 and 16 to 1 and 2. Does that make sense? The technical reason that you can do that is it doesn't matter what order you multiply stuff in. So you can technically make this into 8 over 16 times 7 over 21. Does that make sense? And if you reduce the fraction separately, you don't have to show that step, but that's why this works. So that makes 1/2 times 1/3, which is then super easy, and it's 1/6. But that cross-reducing technique also works for things like fractions with multiplications. So let's look at example 2, part B. Okay, that first expression is like, holy moly, it's already factored. So let's just leave that as 12x squared y cubed. Okay. Does its denominator have a greatest common factor?
Yes.
Yeah, what is it?
2x,
2xy, great. And then we're left with
y plus
3. Just y plus 3, right? I always check by redistributing to see that I got it all. Does that make sense? Okay, times. Now, how about this y squared plus 6y plus 9? What multiplies to make 9 and adds to 6? 3 and 3. So I got y plus 3, y plus 3. Okay. And in this denominator, what's the greatest common factor of that group of stuff? 3y squared. if you want to cross stuff off when you cancel, just don't scribble it out so I can't see what you had, just like cross it off lightly. So does this y plus 3 cancel?
Yes.
Yes. Does the other y plus 3 cancel?
Well, if you redistribute it, like,
Let's just, does it cancel, yes or no?
no.
Yes, it does.
Wait, what?
There are 2 y plus 3 factors in the numerator, and there are 2 y plus 3 factors in the denominator.
Well, I was gonna say you could factor out, it was easier for me to see it with the longer version.
Okay. All right,
Because,
so,
well, you can divide both those by 3, and you can divide both of them by y once, but because you're using it twice, it goes down to the exponent.
if it works, great.
Yeah.
Okay, so let's just think. In your numerator, for me, I found canceling those y plus 3's first be easier, but that's just me. Everyone's different.
Yeah.
So the numerator is 12x squared y cubed. What's in the denominator? Yep, 6xy cubed. Great. So I found it easiest to look at that and look at this in 2 steps. You can actually do it in 1, but my brain hurt. So 12 over 6 makes 2. X squared over x makes x. And then the y cubed over y cubed is done. It's 1. So we're all good. Okay, let's do example 3A and B, and we'll probably pause. All right, so we've done reducing, multiplication. Next, we're going to do division. So I think we discussed on the first day that when you divide fractions, this is the same thing as 3 over 8, big fraction bar, 9 over 4, right? This clearing snow, I don't know what's up with them. And then another way to think about that is, okay, I don't want to have a fraction divided by a fraction. I want to make the denominator go away, which means make that denominator into 1. What could you multiply by to make the denominator into 1? 4/9. And so then all you have is 3/8 times 4/9. And that's where that division by a fraction is multiplication by the reciprocal rule comes from, right? It comes from that. That's why. You can just use it. You can just remember that the second fraction is what flips, but that's the reason the second fraction flips. Is that okay? All right, cross reduce. You get 1 over 2 times 1 over 3, and I wasn't very creative. My answer is, again, 1/6. The answer is not always 1/6, just in case that wasn't obvious. I once made a lesson where I had like 5 answers be 3 in a row. It was really a problem. Okay, so let's do one more. So I got 4 minus x divided by x squared minus 16 over 5. Which one flips?
The one on the right.
The one on the right, exactly. So I have 4 minus x times 5 over x squared minus 16. Okay, lovely. So I'm going to factor the second one. 5 over, how does x squared minus 16 factor? X plus 4x minus 4. And here's the slightly tricky thing in this problem. That 4 minus x is the exact opposite of x minus 4, right? Yeah.
What you can do is factor out a -1.
That's what I was going to say. You can factor out a -1 and make it into x minus 4. Does that make sense? I both took out a negative and flip-flopped the terms at the same time. Or what you could remember is that something divided by its opposite is also always -1, right? Like 5 divided by -5 is -1. So the x minus 4's cancel, and what's your final answer? -5 over x plus 4. Great. So that's it. Nope, over x plus 4. Because the x minus 4, this x minus 4 cancels with that x minus 4.
Wait,
Yes.
To get X minus 4, you have to distribute the negative 1, so that would disappear. And that would be good. So it would just be positive 5.
Let me pause.